experiment. This is a work, a joint effort between different institutions. I would like to thank all the co-authors who contributed with all the material and the model runs. This is a joint effort between Argentina, Brazil, and France. I would like to remark that this is a preliminary work. This is the beginning of the phase. Our motivation was to analyze the ability of high-resolution models to represent organized convection over southeastern South America, and the objective was to perform an assessment based on a model intercomparison, as we also see from some of the work, focused on the precipitation forecast quality during 3 particular events where organized convection was observed. Here we had a total of 10 different model runs. We mostly have the WRF, the Brahms, and the Meso-NH models. Each had different configurations, as we can see. Some of them have no convection parameterization. This is something to remark. And they have different horizontal resolution, initializations, and model domains. As we can see, for Santa Maria, we have different domains that we collected from those different model runs. We have the work from Argentina and from the UBA, from Gruma Group, CPTEC, Meso-NH, Brahms, and Brahms from here, you speak? Oh, sorry. Most of the output temporal resolution was 1 hour, except for the work from Gruma, which was 6 hours. Most of the models had initializations at 12 UTC, but some of them also had at 0. Forecast ranges varied from, forecast leads varied from 36 to 72 hours. So we had different configurations and databases. And to compare the model performances, we had a visual, a subjective inspection for 3 different convective events, 22nd November, 5th December, and 10th December. Based on different model output availability, we focused on a few things. 3-hour and 6-hour accumulated rainfall, and up to 36-hour forecast range, and the initialization was at 12 UTC. We also included 2 satellite precipitation estimates from TRIM, the version 7, and CMORPH 8 kilometers because of the resolutions we are trying to see. We also know the limitations that these estimates have. This is just to show, but Leah, Luis, Christopher, and Renato also showed these events. We can see the systems moving to the northeast. And we can see here for this first case, for the 22nd November, a 30-hour forecast. We have the 6-hour accumulated precipitation, and we also we can see the varied results that we have. The basic differences are based on initialization, model domain, and initial and boundary conditions. Mostly, we can see the differences between a 16 resolution model, the pattern, and another pattern, but with high resolution. The differences are the impact on the model domains mostly. We also here. We also added the estimates to see the pattern. We can see really varied results. I would like to remark that this is a subjective and preliminary work, so there's still a lot to do. For this another case, on 5th December, we have also this system passing through over Santa Maria to the northeast, and we can also see the impact on the initial condition and the resolution and the domain. I'm sorry, the domain. We can see the runs from work CPT and from the National Weather Service and the UBA. And this was another system, also presented by Leah, where a mesoscale convective system was shown. We also tried to see some of the impact of the models, comparing them with the disdrometer hourly rainfall. I will present just for a particular day, for the 11th December. This is the black one is the curve of the disdrometer, and we can see the lag between the models and the observed rainfall. Well, the preliminary results were sensitivity to domain size, resolution and initial conditions, sensitivity to model characteristics between them, and according to these evaluations, it seems that finding an optical balance between resolution and domain size, it is critical. Some future work to include measures of performance, like bias or something else, to facilitate the synthesis of the results and their representativeness, and to refine the intercomparison, maybe selecting similar runs to drive more conclusions and recommendations for operational settings. And also analyze the quality of the ensemble mean, or some other suggestions. Thank you.
We have time for questions or comments from the audience. Someone would like to make a comment or a question? Can I make a question for you? You mentioned that there are some time lag difference between all the models. Have you thinking about what is the cause of them? Could be the cause?
Yeah. Well, we just actually we analyzed one particular case. We see that because of the availability, there were not many cases of rain clear over Santa Maria that we could show the forecast to compare. We saw that the initial and boundary conditions are really crucial. Yeah, they have a great impact on the location and on the time of the rainfall. So that could be something to analyze.
Did you look at any simulation that started in the previous day to see if the lag would be better results?
Yeah, but we didn't find better results.
Mm-hmm. And none of these have any sort of moisture initialization, surface moisture, soil moisture?
Soil moisture, yeah. I think some of them have.
Mm-hmm.
Yeah, I should check, but yes, there were a lot of configurations.
Yeah. So
Yeah.
that's just the beginning of the model intercomparison, right?
Yeah, yeah.
So there are several steps to make things
Yeah,
more
finalize.
clear. So it can, right?
Any other comments or questions for Cynthia? So if not,